All right, so I'm going to look at the last few questions of the 2024 exam that I wasn't able to do in the previous video. It says, consider the graph g1 of x equals e to the ax, where a equals 1 on e. Find the equation of the tangent line to the graph, y equals g1 of x at x equals e. So what we're going to do is we're going to determine the gradient of g1 of x, because in order to determine the tangent, you need to know what slope of the tangent line is. So if we do g1 dash of x, actually, what we'll do first is we'll just determine what g of x, g1 of x is. g1 of x. g1 of x is, okay, e to the ax, but a is 1 on e. So this is e to the x on e. So g1 dash of x, okay, you can use your calculator here to take the derivative, but hopefully you know that's going to be 1 on e to the x on e. Bring the coefficient down, right? Okay, we want to know what the slope of the tangent line is at x equals e. So what we're going to get is 1 on e multiplied by e to the e on e. Okay, e to the e on e. Well, e on e is just 1. So it's 1 on e times e, which is just 1. So we know y equals mx plus c. We know the gradient now is 1. So we know we've got y equals x plus c. Okay. If we substitute in x being e into the original equation, so if we do g1 of e, we would get e to the e on e, which is e to the 1, which is e. So what that means is that's essentially coordinates. It's saying when x is e, y is e. So make y equal e. We make x equal e. Do that properly. And then find c. Okay, subtracting e from both sides, we get c equals 0. Therefore, the equation is y equals x. Okay. So the graph of G1, so that's the first part. Well, it must be a quicker way because it's 1 mark, but we have to show enough working. Oh, yeah, but you don't have to show enough working, but in order to get the right answer, you have to go through that working. So y equals x is the answer, I think. Sketch the graph of G1 and its inverse on the axes provided. Label the equations of the asymptotes and the coordinates of the point of intersection. Okay, let's find the inverse because it says we need to graph its inverse. So G1 inverse of x. Okay, so let y equal g1 of x. So you're going to get y equals e to the x on e. All right, swap x and y. So you get x equals x equals e to the y on e. So you get log base e of x equals y on e. So y equals 1 on e log e of x. Does that look right? Sketch the graph in its inverse. Oh, no, it's not right. It's just e when you multiply both sides by e. You get e log e of x. Okay, so that is the inverse. I suppose, now that I think about it, we didn't need to work out the rule for the inverse. We just needed to graph the first one. Okay, so, I'm really stepping this out, hopefully, but you're going to get y equals e to the x on e. Okay, where is the y-intercept? Well, the y-intercept is when x is 0. So the y-intercept is e to the 0, which is 1. So the y-intercept is at 1. Okay, and it's an exponential graph. So it looks something, well, it's going to have this shape. I'm going to erase it for 1 second. You need to know where the intersection is. Now, an intersection between an original graph and its inverse must intersect on the line y equals x. So you're going to get x on e. Can we solve it this way? Log e. You know what? Why am I doing this when we can use a calculator? So I'm solving e to the power of x on e equals x. Okay, that didn't seem to work for some reason. So let's set it equal to its let's set it equal to the inverse function, which is e multiplied by log e of x. Okay, for some reason, I'm not sure why it's not liking that. Maybe you can let me know. What we can do now instead is we can graph it, e to the x on e, and the other one is e multiplied by the natural log of x. And if we just graph them both, undefined variable, this e, they don't like that e, so let's go back. Okay, so you get this. Okay, the blue line intercepts at 1, 0, so it's the inverse, so it intercepts there. If we go analysis, G-solve, intersection, they intersect at 2.7183, which hopefully you recognize is E. I don't know why it didn't solve it algebraically. Maybe you can let me know. So if we graph this, they intersect at 2.7 approximately. So where's that? It's about there. So this graph needs to go through 0, 1. And then this one needs to go through 1, 0, and then intersect at EE. This is the most frustrating exam I think I've ever done. Maybe it's hard because I'm doing it on a computer. This is at EE. Okay, label the intercepts. So that's at 0, 1, and this is at 1, 0. I'm sure I just wasn't able to solve it properly. It's kind of bugging me why I wasn't able to solve it. So let's just do this. So let the function equal x. So you're going to get x on e equals log e of x. Then you've got an x on both sides. I don't know. Calculator didn't like solving it either. So anyway, that's our answer. Now let a equal -4. Consider g2 of x equals e to the -4x. Find the rule for g2 invert g2 inverse, the inverse function of g2. Okay, what is g2? So g2 of x is, I don't know why I'm writing this, -4x. Okay, let y equal g2 of x. You're going to get y equals e to the -4x. Swap x and y. So you're going to get x equals e to the -4x. E to the -4y. e to the negative 4y log base e of x equals negative 4y. So y equals negative a quarter log e of x. Just says find the rule. So therefore, G inverse, G2 inverse of x equals negative a quarter log e of x. Find the values of x where G2 intersects with its inverse, correct to 3 decimal places. And the values of x where it intersects with its inverse. Okay. It says the decimal places, so we can use the graph screen. So e to the negative 4x now. And this is negative a quarter. Negative a quarter, yeah, natural log of x. Graph them both. Zoom in. Analysis. G solve, intersection. Okay, luckily we do get 3 intersection points, 0.028. One mark question, so we just got to write the answers. So x equals 0.028. Okay, I wrote them down earlier, 0.301. If we go to the next one, 0.301. And the last one is 0.894. If we go back here, 0.894. So that's all of them. I think that looks good. Okay, this question I think is near impossible to do under exam conditions. Anyway, let me explain. I'm going to have to explain using Desmos, so give me a sec. Okay, so let's just explain the question first. So the value of A determines the number of intersection points of the graph of G and G inverse. Complete the following table by stating the values of A in each case. Okay, I'm sure there's a thread or something that I needed to pick up in the previous questions to help me with this. But having said that, I don't know what it is. So G of X equals E to the AX. Okay, if you let y equal G of X and then swap X and Y, you'll get the inverse function as 1 on A log E of X. So basically, these values of A, changing the value of A is going to determine how many points of intersection you get. It says when A is between 0 and 1 on E, you get 2 points of intersection. So let's go over to Desmos and explain. So on the top here, we've got G of X. On the bottom, we've got F of X, which is the inverse of G of X, okay? The part said, it said that when it's between 0 and 1 on E, so 0 is there, you can see that that's got 2 points of intersection when it's a bit larger than 0. Okay, 1 on E. Okay, so if it's a bit less than 1 on E, it's a bit less than 1 on E. So you get this situation going on just as it crosses 1 on E. So it goes there. So crossing 1 on E from 0.4 to 0.3. You start to get, you go from, you get 2 intersections between 0 and 1 on E. At 1 on E, you get 1 intersection. And again, let me just show you. 1 on E, you get 1 intersection. Okay, they just touch once. So we can answer this first, but I can answer the second box. When do you get 1 intersection? You get 1 intersection. Let me have a think. Okay, so yeah, you get 1 intersection at 1 on E, because that's when they just touch. You also get 1 intersection, and how you're supposed to know this is just beyond me in an exam when there's time pressure. Between negative E and 0. So let me explain. Between negative E and 0. So a bit less than 0. And so firstly at 0, it's undefined, or one of this function is undefined. A bit less than 0. You can see they've got 1 point of intersection. Now, it does this weird thing where they sort of come together and there's only one point of intersection. There's only one point of intersection until you get to negative E. One point of intersection, remember, E is approximately 2.7. So negative E is negative 2.7-ish. So we got one point of intersection. Even at negative 2.7, that's just less than E. We've still got one point of intersection. But as soon as we get less than negative E, we're getting multiple points of intersection. We're getting 3 points of intersection. So set it up on Desmos yourself and have a play around. So I reckon you get 3 points of intersection when A is less than negative E. When A is less than negative E. And you get no points of intersection when A is greater than 1 on E. So let's just look at this part again, just so we drive the point home. If A is less than negative E, so let's put it at negative E. Okay, at negative E, that's the last time we get 1 point of intersection. Less than negative E, like negative 2E, would give us 3 points of intersection. So anything less than negative E gives us 3 points of intersection. Okay, the other one we said was anything greater than 1 on E. Greater than 1 on E. Okay, 1 on E is approximately 0.367. That's when they touch once. If I pick a number greater than that, pick a number greater than 1 on E, they're going to just keep diverging and they never touch again. So good luck doing all that on your Casio class pad under the time conditions, but I think that's the answer. So just to confirm, I think these are the answers. Let me know what you think. And good job doing that exam. I thought that was quite challenging.